Hello, my name is Omar Cruz. I am the Director of Education and the Clinical Herbalist for Himalaya Drug Company out of Bangalore, India and Houston, Texas. Let's talk a little bit about bitter melon. Now, to talk about bitter melon, we can actually take a moment to appreciate plants in terms of their own environment, their own ecology, if you will, and their own immune system. You see, plants over the millennia of their existence have developed their immune system to become more defensive. And if you can imagine just for a moment, being a plant, you can't run away from the sun, right? So you got to develop a tremendous amount of antioxidants to your well of immunity, but you also have to develop these chemicals of defense because you're inevitably going to be food, or at least a temptation of food for somebody. The plant, in this case bitter melon, created a very, very unique defense system, and it was particularly a defense system against cows. You see, if cows were to consume all of the leaves of this plant, and think of leaves on a plant as solar panels. That's exactly what they are, of course. The chlorophyll is converting sunlight into sugar, and from that point into energy for the plant. So, if cows over a great amount of time were consuming all of its solar panels, it had to create a chemical to defend itself from those cows. And what it created was an amazing polypeptide, okay? This polypeptide-p, which is what it's been called, is an actual peptide that is an insulin mimetic. So in drug design, insulin mimetic literally means a mime. You know, like someone who's acting as if they're in a particular situation, or they're acting as if they are in a set or construct when it doesn't actually exist. In chemistry, an insulin mimetic is a compound that looks and acts like insulin to the receptor sites. So when a cow would eat too much of this particular plant, because the plant created these polypeptides, it would actually start suffering from low blood sugar and walk away and perhaps eat something else. Now, the beauty of the defense that it created is this. The insulin that's produced by cow is also very similar to the insulin that's produced by humans. So we actually use bitter melon and we extract part of its immune system, which is the polypeptides, so that we can have an adjunct effect to our own insulin production. That's one aspect of its effectiveness. The other is that it actually can increase insulin sensitivity. Now, this is a whole burgeoning aspect of endocrinology in which we're seeing that insulin, the hormone, although it's produced normally out of the pancreas, it may have difficulty communicating to the receptor site. And bitter melon, according to the traditional systems of science, as well as the clinical trials that we've conducted, seems to increase the sensitivity of human-made insulin to the receptor sites. This is actually studied in what's called a postprandial blood sugar test. Postprandial blood sugar tests are different exams from your fasting blood sugar. Fasting blood sugar usually occurs after 12 hours of not eating, and then they test how low your blood sugar has gone. Postprandial tests are a whole separate type of categorization of blood sugar testing in which they give you a prescribed amount of sugar, and then they test how much sugar you have left after 1, 2, 3, or even 4 hours after consumption. This is a test that'll tell us not only if you're producing insulin, but how much insulin is actually communicating with the receptor sites and opening those cell walls of the muscles and the liver to take sugar out of the blood and convert it into glucose 6-phosphate, which is a nice storable form of long-term energy for the body. So bitter melon has been shown to do exactly that. Decrease the amount of sugar in a postprandial setting so that we can actually say with some definity or with some assuredness that it increases the communication of insulin to the receptor site as well as acts like an insulin mimetic in the blood.